So again, this is a heRo3 webinar with an exclusive focus on oncology use cases and applications. And heRo3, in a nutshell, we think is quite simply the most important advance in health economics modeling since the spreadsheet. We know that some of you who are on the webinar are actually using heRo3, so hopefully you've been convinced of that by now. Others of you who may be new to the application, I don't know that we'll succeed in convince you at the end of the hour, but hopefully we'll intrigue you enough so you'll want to look into it a bit further. So first of all, what is heRo3? Well, heRo3 is an enterprise, mobile-friendly, interactive cloud platform for building, running, and securely sharing health economics models. It combines the presentation capabilities of modern web technologies with the analytical power of the programming language R. It's got a very visually appealing and engaging user interface that requires no prior specialized knowledge of R. So it enables effectively people to build programs, run programs in R who are not R programmers and have next to no experience programming and working in R. And one of the things that it also does, which is a real time saver and money saver, is that it automatically generates a full range of output displays that are typically used in cost-effectiveness models. And we'll illustrate that as we go through the application today. So what precisely are the benefits of heRo3? We think there are a number of them, and these we think are the most important ones. First of all, it saves significant time and money. It significantly reduces the time needed to develop Markov cohort and partition survival models. And by significantly, we're not talking a 10 to 20% reduction in the amount of time it takes. It's at least an order of magnitude reduction. And we'll demonstrate some of that today. And if you talk with anyone who's actually been using heRo3, I think you'll find that they confirm that the savings are at least what we assert them to be. And it also is very empowering. Some people have been concerned that heRo3 might foreclose opportunities for HEOR personnel in companies or consultancies. We think it's going to do just the opposite. It's going to make HEOR analytics available on a real-time basis to clinical development and product planning teams, and it's going to make us as HEOR professionals much more relevant to the companies for which we work. Second, it also enhances transparency for a variety of reasons. First of all, heRo3 results or produces a very compact representation of a model. And Excel has the reputation of being transparent. But in reality, as we're going to show you and hopefully convince you, Excel is anything but transparent. We think that heRo3 is the essence of transparency because of the compact depiction and description of models. It's also transparent because you get a full listing of the inputs, the outputs, the intermediate calculation with every single model with the push of a single button. And that kind of transparency is very, very rare in models in Excel. It's also robust and reliable. The calculations in heRo3, they're all based on a heavily tested open source modeling package and R, and programming errors simply are much less likely in a heRo3 model than they are in Excel, and the models are much easier to QA as well. And finally, we think that heRo3 results in much improved communication. There is an interactive user interface that enhances engagement and understanding. It's very heavy on transitional animation. And part of the reason for that is because people pay attention to things that move. So we take advantage of that and exploit that in heRo3 to engage users and viewers. And this is an example of the kind of functionality you get in heRo3. This is just a GIF of a screenshot of the value-based price calculator in heRo3. This is a waterfall diagram that you get in heRo3, toggling back and forth between waterfall and a bar. And you can see that, and here's the PSA functionality. And we'll be demoing all of this live, but this is what you get in heRo3 when you deploy any of these features or functionality. So we promised you that today was going to be about oncology applications. We sort of think of oncology as being heRo3's sweet spot. It handles Markov cohort models very nicely, thank you, but this is really the sweet spot. There is no other application out there that comes close to doing what heRo3 can do, and we're going to spend the rest of the hour talking about this functionality. So the platform allows for very rapid development and iteration of partitioned survival models, which are really the bread and butter of economic evaluations in oncology. And you literally can build simple partitioned survival models in minutes, not hours, not days, not weeks, minutes, and we're going to do that. It's also powerful enough to easily handle much more complex models and very advanced approaches to survival modeling. You can model on and off treatment as separate health states. For example, discontinuation of treatment in immuno-oncology oftentimes does not occur when patients experience disease progression. You can handle that easily in heRo3. Response-based models, the list goes on and on. Bottom line, it provides flexibility to meet rapidly changing needs. If you're going to be part of a mission-critical operation feeding into clinical development, product planning processes, you need to be able to turn things around on a real-time basis, and this application gives you that capability. So what I'd like to do right now, instead of asserting all of these attributes of heRo3, I'd like to turn the presentation over to Jordan Omdahl. Jordan is the lead designer on heRo3 and leads the development team here at PAI, who's been working on this application for over 3 years. And Jordan's going to do a deep dive into functionality of heRo3 in the area of oncology. Jordan?
Great, thanks, Jerry. Really the key to building partition survival models is working with survival data. That is, generally speaking, the most complex part of doing a partition survival model. So I think we should spend some time talking about all the functionality that heRo3 provides in working with survival data. Specifically, heRo3 comes with support for a wide variety of different survival distributions. You can work with life tables, you can work with Kaplan-Meiers, you can work with parametric functions of all different types, including exponential, Weibull, log logistic, log normal. But there's a whole set of other distributions that you can work with in that category. There's mixture and non-mixture cure models. You can even model using restricted cubic spline models. So really, heRo3 does not limit you at all in terms of the different types of distribution you can use. In fact, it makes all of these types of distributions that much more accessible rather than having to program it yourself in Excel. Now, once you've got those distributions set up, heRo3 also provides all kinds of tools for working with those survival distributions to modify them and combine them. For example, you can easily apply treatment effects like hazard ratios or acceleration factors to any distribution. You can join two distributions together, like joining a Kaplan-Meier distribution with a parametric projection. You can even combine survival distributions as independent risks. For example, maybe you've got one distribution that's disease-specific survival and another one that's background mortality. You want to throw those two together. Easy to do in heRo3. And not only that, you can combine any of those operations in any order you like to build out your survival modeling approach for your model to meet your needs. Really, this functionality is there to provide you infinite flexibility in deciding how to model your problem. So let's do a little example. So we're going to do an example where we're modeling a novel immunotherapy, and we're starting with some Kaplan-Meier data that we've been given. And so that's easy enough to plug into heRo3, and a little bit later we'll show you, how that actually gets set up. But we're going to start with our Kaplan-Meier data here. But of course, that only goes out so far. Our trial data in this case goes to 5 years. So let's take a look at what we can do next. So now we can project survival from that Kaplan-Meier using a Weibull distribution. We'll take it out to 20 years. But this is still not quite right for our immunotherapy agent. The survival at the tail is a little bit too low. So it doesn't really capture the long-term survivals that you can sometimes get with those IO agents. So moving on, we can maybe replace that Weibull model with a cure model to reflect the fact that some of our patients are going to experience long-term survival. But now we've got some of our patients becoming immortal at the end of the model because we're not incorporating the background mortality. So we can add that in. Now you can see it starts to dip a bit at the end. But that's still not quite enough. patients are probably subject to a little bit higher than general population mortality. So we can add in a little bit of excess risk, and now our survival model approach is perfect. So, this is just an example of what you might go through when trying to find the right way to model your intervention. What does that look like if you try and do it in heRo3? So what it looks like is this. You've got a single table with only 9 entries in it, 9 different formulas that you've got to set up. And the formulas themselves are actually really easy to understand using, basic verbs like join, which allows you to join 2 curves together. And so, really the entire content of all of our formulas for this setup, it's less than 480 characters. You could fit into 2 tweets. That's how compact our representation of that survival modeling approach is in heRo3. Whereas if we wanted to do that in Excel, this is what it would look like. So on the left, you can see we've got all of our different calculation cells that we would have to set up to calculate survival probabilities in each cycle. And we zoomed in on this tiny segment here, and you can see there's a lot going on. So we're talking about tens of thousands of calculation cells and hours or days to set up with a very high risk of errors and a great deal of difficulty in QCing it. And of course, once we zoom in on any one of those formulas, they may look like this. They may be very, very ugly. I think everyone who's worked with Excel models has seen a few formulas that look like this, where if there's an error in it, good luck finding it. And so really with heRo3, we strive to make our calculations really nice and compact, so you're dealing with 10 times, 100 times fewer formulas, and the formulas that you look at don't look like this. They look nice and clean and easy to understand. So with that, we can jump right into a demo. And so we're looking at the web browser now. We've got heRo3 opened up. This is more or less the same model that we were looking at before in the Excel example, in the PowerPoint example, except we've built it out a bit. We've added 2 strategies. So now we've got immunotherapy and targeted therapy that we're comparing. And just, of course, this is a simple 3-state partition survival model, so our states are progression-free, post-progression, and dead. I do want to note, though, that heRo3 is capable of doing more complex partition survival models that can have 4 or more states. For example, you can model on or off therapy as separate health states. Really, you can do all kinds of things with it, but we're just doing a simple 3-state example for this demo. And so now that we've done that, so when we've opened up our model, I'll just show you quickly the results for it. So this is the trace page, which shows the probability of being in each of those health states over time. Right now we're looking at targeted therapy, and you can see for targeted therapy, we have a similar sort of setup as what we showed in the slide deck. We've got our Kaplan-Meier segment that goes to 5 years, followed by a parametric projection. In this case, it's just a standard Weibull model. And then for immunotherapy, you can see we just switched to immunotherapy over here. Now we've got our 5-year Kaplan-Meier segment followed by our cure model with our excess mortality added on. And so let's spend a little bit of time showing you how I actually set that up and how it can be so simple to set up when compared with Excel. So the first place we need to go is to the survival distributions page. And you can see there's a few more formulas here than we showed in the Excel example, again, because we're modeling 2 strategies now instead of 1, but it's really not too much. We've, maybe not even quite doubled the number of formulas for those 2 strategies. And let's start by looking at the modeling of progression-free survival. And so for progression-free survival, we have a few different, we've got our survival distributions, our individual sort of pieces of the survival distribution survival modeling setup, both for immunotherapy and for targeted therapy. And each one has 3 segments. It's got the Kaplan-Meier, it's got the parametric projection for immunotherapy, it's a cure model, for targeted therapy, it's a Weibull, and then it's got an overall segment which joins those 2 together and adds the background mortality. So starting with the Kaplan-Meier segment for PFS for immunotherapy, there's just a simple formula here which takes a table, which we defined on the tables page over here. So on the tables page, we can paste in all of our Kaplan-Meier data, which shows the times and the survival probabilities for PFS, for OS, for immunotherapy and targeted therapy. So all of that is just here, and we would have gotten it from our statistician and just pasted it right into this page. And then back on the survival distributions page, we simply reference that table in our formulas to turn it into a survival distribution that we can use in heRo3. And so like that, we've set up our Kaplan-Meiers. And then our parametric distributions in this row here, we simply use another function to say that we're creating a Weibull cure model. We reference shape and scale parameters that we've defined on another page on the variables page. And then that's set up. And then finally, we join the two curves together, our Kaplan-Meier and our cure model. At a specified cut point, we add on the general population mortality, which is here, defined here. And that comes from a life table that we pasted in right here. Could have come from anywhere, but we just paste it right into our tables page. And we turn it into a survival distribution and join it together with everything else. And like that, we have our survival modeling set up. I built this model specifically for this presentation, and I don't think it took me more than 20 minutes to set the whole thing up for both of these strategies. So really, that's how easy it is to work with. And the formulas that sort of handle this setup process for defining the different distributions and joining them together, they might look a little bit complicated at first, but really, I mean, to get to understand them, you're just talking about a 2-page cheat sheet. Each one of them is really easy to understand on its own. And then once you understand the individual operations that you can do to create survival distributions and put them together, it becomes a real breeze to just sort of combine them and do what you need to do. So here we're looking at the trace page again. We've set up our survival modeling approach for our two strategies. And we're just going to very quickly go through this and see what we can do with these results. So the first thing we're going to do is look at the sidebar over here at the right, on the right-hand side, which allows us to configure our results display. So we can do things like change the color, maybe come up with use a color scheme that looks a little bit more Easter themed instead of the primary colors theme that we had before. Below that, there's a section called user override values, which allows us to pin various inputs to our model and then change them while looking at the results pages. So, for example, maybe what we want to do is change the probability of getting cured for immunotherapy and see how that affects the results. I'm just going to change that, and model will recalculate, and then we can see the results will update. You can see survival went up a bit, and all we have to do is hit that little arrow and it will reset. Now, maybe we've got this set up and we show it to our statistician, and the statistician says, you know what, for looking at targeted therapy, we think this projection is a little bit too pessimistic. It should be a little bit higher around year 10, year 15. So maybe we should use a log logistic model instead of a Weibull model. Now, if we were doing this change in Excel, it might take a little while to set up, figure out what the parameterization is. But in heRo3, it's actually really easy. So I've already pre-populated this model with the parameters to use. And so I'm just going to create another survival distribution, target OS log logistic. And I'm going to set up the formula for that, and it's really easy. I'm just going to tell it that I'm setting up a log logistic distribution, pass in the appropriate shape and scale parameters, referencing what we already have on the variables page. And that creates our log logistic distribution. Now all we have to do is tell it to use that instead of the Weibull. And now we're using the log logistic distribution, so we can go to the results page and see that our survival at the tail is going to go up a bit. And so that's how easy it is to make changes to your survival modeling approach when using heRo3. Even if you hadn't anticipated at all using a log logistic distribution, it's that easy to switch it to using one, and other changes to the survival modeling are similarly easy. Now that we've got this set up the way we want, we can very easily export it to an image, maybe throw it into a slide deck, and so all we have to do is hit the export to PNG button, and then an image of that chart will download for us to throw into our slide deck. Moving on, just to show off some of the other results, we can look at outcomes. Here we're showing bar charts for outcomes, breaking it down by strategy and by health state. We can turn those into waterfall charts. We can switch between different outcomes, for example, show life years. And really, models in heRo3 can show any kind of outcomes that you want to set up. Really, whatever the modeler wants to include in the model can be added. It's not just life years and qualities. We haven't hard-coded those. We can also show costs, again, bar chart and waterfall chart. We can play with the override values and see how those affect costs. We're a little bit short on time, so we're not going to cover every output display, but just very quickly, we have a value-based pricing calculator. We also do deterministic sensitivity analyses. So the way those are set up is you go to the DSA inputs page, you check the variables you want to vary in that DSA, you specify the low and high values over which you're going to vary them, and then when you go to the DSA page, you can run it and you'll generate nice-looking tornado plots like this. And you can even drill down in these tornado plots. For example, instead of looking at life years, you can look at instead of looking at qualities, you can look at just the progression-free qualities, and then the tornado plot will automatically update to show you what affects that. Finally, we also do probabilistic sensitivity analyses, so you can check the set of parameters you want to vary in your PSA, specify a sampling distribution, and then when you run your PSA, you'll get a full set of graphics showing you what the results are for that. So here we have a little scatter plot showing how the simulations fall in terms of the difference in outcomes and difference in cost. And then finally, we can, once we've built our model and we're happy with it, we can export it. So the export to Excel option I want to cover quickly. So that allows you to generate a workbook like this one, which has all of the inputs to your model as well as all the results of intermediate calculations and results of final calculations. It doesn't produce an executable Excel model, but it does give you all of the sort of the inputs and the calculations that were needed to run your model, and you can use this to audit your model or even generate your own tables and figures if that's what you want to do. So moving back to the slide deck, I do want to mention, of course, that even though this presentation was focused on partition survival models, heRo is also quite good at working with Markov models. It gives you all kinds of functionality to define very complex transition matrices with only a few short and easy to understand formulas. It does things like automatically calculate the complementary probabilities, so you don't have to do a whole bunch of one minus the other transition probabilities. All your transitions will always sum to 1 using that functionality. You can easily create multiple transition matrices to incorporate time dependency to do things like model age-specific mortality. heRo3 also makes creating tunnel states easy, so if you want to have mortality depend on time since disease progression, you can quite easily do that. And so just a quick example of what a transition matrix looks like in heRo3. It's going to look something like this, where, in this case, we've only got 7 different formulas, and we've got all kinds of time dependency built into this transition matrix. So a very quick setup, low risk of errors, easy to QC. The exact same transition matrix setup in Excel looks like this. So we've got to have a whole bunch of different transition matrices. Each one's got to be much bigger. And so we're talking, again, tens of thousands of calculation cells and much longer time to set up, larger risk of error, much harder to QC. And so, there's all kinds of reasons why heRo3 saves time and money. I think we've probably convinced you on some of them already. But just to hit a few more, one of the nice things about heRo3 is it comes built in with all kinds of graphical outputs. It comes built in with our tornado plots, the waterfall charts, the efficiency frontiers, the bar charts. And it also comes built in with all the functionality you need to set up your deterministic sensitivity analysis, your probabilistic, your value-based pricing. All of that is automated, easy to set up, and built in, whereas with Excel, you've got to do it yourself, and that involves a lot more time and money to do. And then finally, heRo3 models can easily be shared and exported. We've already covered the export to Excel. But I also want to mention that it's very easy on this platform to share a model with another user. You just start typing in their name, and then you hit the share button, and then they will receive the model. And then also, in addition to the export to Excel, you can export to R, which allows you to run your model offline, run it on your own computer instead of running it on our cloud platform if that's what you want to do. And so with that, I'll hand it back off to Jerry.
Yeah, I think at this point in time, what we'd like to do is we're a little bit ahead of schedule, which is good. Open it up to questions that some of you may have. Again, we've got folks from colleges and universities, folks from companies that currently are using heRo3, some in oncology, others perhaps not, and then we have other folks from companies that have not yet had the opportunity to use heRo3 but have oncology pipelines or marketed products and express an interest in heRo3 for evaluations that they might want to conduct. So do you know how to unmute folks?
I can either mute all, and then
Sure.
we would request that if you're not speaking to please mute your line just to avoid background noise. We can start with that.
That would be great. Then let's see if this works.
Give me 1 second.
You may or may not identify yourself before your question because everyone is anonymous. If you want to remain anonymous, you may do so. If you'd like to identify yourself, that's fine as well.
So there was a question, just to let you know, in the chat, are you going to share the model as a use case? So I'll just tee that up. I don't know if Jordan can see that.
We could certainly share the model. If you email us afterwards, we can make sure that you get access to it so you can play around with it and see exactly how it was set up.
We actually have the TA447, which was a nice technology assessment of pembrolizumab, or Keytruda, in NSCLC. That's actually as a demo model on the platform right now. That's in the template section, is that correct?
Yeah, it should be available to every user as a template.
So I think everybody on the call right now on the webinar has access to the platform, so everyone should be able to
if they're a
modeler.
Currently only modelers see the templates, so that's something we may change.
Okay. And we certainly can share this example as well post the webinar.
So I'll go ahead and unmute. Everyone should be unmuted unless you use your own line.
Any questions? I think you're all unmuted now, so hopefully everybody won't jump in at the same time.
What is it like when you export heRo3 model into R?
Sure. So what you get when you export the model into R is you get essentially a folder that includes a file that includes the data for your model, as well as an R script that will allow you to very easily run it. And so really all you need to do is, you make sure you have R installed, you open it up, and then you run the file, and it should automatically run your model and for the results in an object that you can, examine or do what you like with. It's also possible to run your model with line-by-line debugging if you want to know exactly how your model is being evaluated by the R package.
So, this is, so we are not, the heRo3 application is not holding your models and data hostage should you want to get off the platform at any time. All of the models and data can be exported to RStudio projects.
There's no analysis that can't be run offline once you've exported your model. So, yeah, all of the functionality is there, but the user interface, that's really the part that you're paying for.
Other questions? Okay, well, let me just talk a little bit about students and faculty and current licensees and those who don't currently have licenses. The heRo3 is currently being made available to full-time students and faculty on a worldwide basis, and we're very proud of the fact that uptake in academia is been moving along nicely. In fact, we got a email last evening from a professor at Johns Hopkins University who taught modeling, and he actually provided us with his course deck, and there were some very nice slides there depicting what models were representations in Excel versus heRo3. So for any students and faculty who are interested, increasingly there's a body of material available for instructional use, and all of the faculty with whom I've spoken so far would welcome sharing their course materials with either other faculty members or students. So if you're interested, just send an email to heRo3support@pai2.com, and we're happy to put you in touch with those other folks and supply whatever instructional content and material we can. For current licensees, this question has come up. There are some companies that have enterprise licenses, but there are particular groups, franchises that seemingly don't know how to gain access to the application. So what I would suggest there is reach out to the HEOR group, your own internal group for model builds. If there appear to be silos and that's not happening, you can contact us and we can also help with model setup. And then finally, if you're interested in a license, you're not currently using the application, there's a range of licenses that are available basically to meet every budget. We are pricing, for those of you who are paying subscribers, intentionally pricing heRo3 to leave money on the table compared to what companies would spend to build models in Excel. And that's very much our strategy right now. We've got uptake at over a dozen companies, and that is moving along nicely, and we want to make certain that the value proposition is very strong and very persuasive for this new platform. Go ahead.
So we did get two more questions.
Sure.
One being, please describe the data sources used in heRo3.
Yeah, so to be clear, heRo3 doesn't come with data sources. You bring your own data to it. So whatever you want to model, you would put the data in. And Hero makes it very easy to do that because, you know, on the tables page, you can just create new tables and paste information in from Excel or from tables on the web. But heRo3 is not sort of currently connected to any data sources. It's really a tool for people to help build and share and work with models.
So the next question sent through the chat was, my thinking is to use heRo3 to build the basic model first and then use R to add complexity to the model. So after export, the scripts will be R scripts. I think that's a two-parter kind of.
It doesn't quite work like that. So it doesn't turn your model into...
Could you repose the question again, because to make sure that what it was? Just restate it?
I'm reading someone else's question, so it's difficult for me to restate someone else's question.
Go ahead.
But yeah, so it doesn't turn your model into an R script. And really, the way Hero represents models is as data. So your Hero model is really a set of tables which define the strategies in your model, the health states, the different results to be calculated, the life years, the qualities. And so your model is sort of represented in a table, and in that table there's various formulas which handle the calculations. But it doesn't turn your model into a script. Rather, the script is just something that reads in that tabular data and then runs it using the open source R package. And so you can certainly sort of edit the model offline in R, but I wouldn't want you to sort of think that it works differently than it does. So it doesn't generate a scripted version of your model. Really, it's a set of tables which then the R package runs.
So another question was, are you going to have more such use cases in the future for more complex Markov and PSMs? And excuse me if I interpret your questions incorrectly. I'm just going off the chat.
Yeah, so we have a number of templates already populated on the platform which look at other use cases, but of course we're always looking to add to them. We'll continue pushing out additional templates in the future. To tackle different kinds of problems and more complex problems.
So, Jordan, let me just ask you a question on the fly. What if somebody wanted to add or create a four-state partition-survival model with the three states that we have in the simple model, but add another state for time on treatment based on data from an RCT? How might that be done?
Sure. So let me give an example of that. So what we might do is create a custom partition survival model. And so that's a special type of partition survival model that we have, where you can define your own health states. And so I just created a blank one of those, and we can create health states for four health states. We can do progression-free, on treatment, progression-free, off treatment, post-progression, and then death. Right, so that's our four-state partition survival model, and then we can go on to the transitions page and define exactly how patients move through those four health states. And that would not be terribly hard to do. I can give you another example of a sort of a custom partition survival model that we've already set up. So in this one, we've got 4 health states: response, relapse, refractory, and dead. And in this model, it's set up such that patients initially can either go into the response state or the refractory state, depending upon what the response rates for the individual strategies are. And then, for patients who go into response, they can go on to relapse and die. And for those who go into refractory, they can move to the dead state eventually. And so just to show you what that looks like in the results page, on the trace page, the patients sort of are initially split into to response, refractory, and then the response patients, start relapsing and dying, and they're dying. And so that's not a particularly complicated setup. There's all kinds of more advanced partition survival models that you can create using this custom partition survival model functionality.
There was a follow-up question for data.
Yep.
So if I license heRo3 to use my own data, does the data need to be in a specific, I'm guessing common format is what they're saying, or as part of the license you adapt the R code to the data structure of my data source?
Well, that's a very broad question, but I think the answer is that, heRo3 lets you put in just about any type of tabular data that you like, and you have all the functionality that R provides for, transforming that data to do what you like with it. Just as an example, we have a function for doing lookups on tables, and so if you've got a table of medication costs, or if you've got a table of adverse event costs, you can do lookups on that. And so I don't think heRo3 is terribly opinionated about what exact format your data is in. It'll give you the tools to work with it, and we're happy to discuss further any particular use cases you have in mind.
And then we have a question on if you could demonstrate, again, how to specify survival curves in heRo3, especially when there's a mixture of survival functions involved.
Sure. So let's go back to our model we started with. So specifically, the question was sort of how to work with survival distributions to create a mixture of survival distributions.
It's the second portion of especially when there's a mixture of survival functions involved. So I'm assuming something like the join function that you were showing, or adding the hazards for the general population mortality.
Right. So let's do something basic. So I'm going to create just a variable here, a survival. Oops, I'm on the wrong page. I'm just going to go to the survival distributions page, and I'm going to create this variable dist1, dist2, and dist3. So dist1 is going to be an exponential distribution. So the way that's set up is we have this function define survival, which allows us to create a parametric survival distribution. And the first argument tells it to do an exponential distribution in this case, or we can set it up to be a Weibull or something else. And then after that, the additional arguments specify the parameters for that distribution. So for an exponential distribution, we need to pass in the rate parameter. And so this gives us an exponential distribution. And so for dist2, we're going to do the same thing, except for this exponential distribution, we'll make the rate a little bit higher, so patients will die faster on that segment. And then dist3, we're going to join those two together. So we'll use the join function. And then for the first argument, we're going to pass in whatever the first segment is, which in this case is going to be dist1. The second argument is the point at which we switch from dist1 to dist2. So at this, we'll just make it 40 months. And the third argument is the second segment, so which will be dist2. And so dist3, essentially what that's going to be is a piecewise exponential curve where up to month 40 it's dist1, and after month 40 it's dist2. Now we can change this if we want. We can instead do a mixture if we didn't want to join them. So we could do dist1 and then specify. So what mixture does is it takes two distributions and it puts them together as if there's two separate groups with different sort of probability weights. So for example, for this one, we'll say that 30% of patients use that. Dist2, maybe 70% of patients use that. And so that would give us a mixture of those two exponential models, an exponential mixture model. And then, we could even combine that with the join. So you can do a join of this mixed model between those two exponential curves and then join it with some other distribution that we've set up. Maybe, and so, I mean, really, that's the way it works. You have a set of functions for creating survival distributions. In this case, we were doing simple parametric curves, but it can be anything. It can be parametric cure models. You can even actually, on the platform, do curve fitting and fit parametric curve models to some time to event data. So the survival models can come from anywhere. But once you have them, you can easily use these different functions to combine those distributions in various ways by mixing them or joining them. You can apply hazard ratios, so we can take this and apply a hazard ratio on top just by doing apply HR, then maybe apply a hazard ratio of 0.5. So, I mean, this is basically how you work with survival distributions. You start by defining the individual pieces, and then you can use these functions to modify them or piece them together, you know, however you need to solve the problem that you're modeling. And we have reference material on all of these functions that you can use, which we can link to after the webinar.
Still questions?
Not in the chat at the moment. That was the last one in the chat. Oh, can heRo3 do budget impact modeling, microsimulation model, and value of information?
So value of information is built into the PSA module, so I can just show that briefly. So here you can see we have expected value of perfect information. So in this particular model, the ICER was around 35K, so you can see that you know, it peaks around there and then drops off. We don't currently do budgetary impact models and microsimulation models, though those are areas of possible future development.
We'll wait another 30 or 60 seconds in case any other questions come in via the chat room. Jordan, anything else that you think we should cover in terms of functionality before we?
Sorry,
oh,
one
I'm
more.
sorry.
Can it also model semi-Markov models?
Yes. So in particular, the Markov models that you can set up here, they can the transition matrix, the transition probabilities can vary both on the cycle time and on the amount of time you've been in the state. And so there is full flexibility there in terms of setting up your Markov models. Again, you can have transition probabilities that depend on things like the age of the patient. You know, the older they are, the higher the probability of death. You can also do things like changing the transition probabilities based on how long you've been in a given state.
Why don't you just open up a Markov that with time dependency and
Sure.
state dependency, and because it sounds like there are also some folks on the line who perhaps are unfamiliar with the functionality of the platform in that arena.
Okay, let me find the. Here we go. So in this particular model, we've got 3 health states, and these transition probabilities, there are 2 different types of time dependency here. So in these transitions, and this is the transition from the well state to the well state to the dead state. There's this variable reference here, P death well, and if we trace that back to the variables page, what we'll find is that this is actually a lookup life table that we defined, where it looks up the appropriate mortality rate for the patient's current age. And the patient's current age is basically just whatever their starting age is plus whatever the current model year is. And so when we define that time-dependent transition probability, and when we put it on our transition matrix, it will automatically generate a different transition matrix for each model cycle with those appropriate death rates substituted in. And similarly, we have the probability of going from sick to dead in this model, which is based off of a survival distribution that we've defined elsewhere, where essentially we're calculating that transition probability based off of the probability of experiencing an event using that survival distribution. And so the longer, in this case, the longer that you've been in the sick state, the higher the probability that you'll die based on that event probability. So in that case, we're creating tunnel states automatically just by sort of creating a time-dependent formula. It's a state time-dependent formula. And so this transition matrix is actually the same one that we showed in the Excel deck, where, just to go back to it, the Excel representation of that transition matrix, or the set of transition matrices, would look like this, where you'd have to have a different transition matrix for each of the cycles, and each one would have to be a huge transition matrix, which would largely be a sort of a sparse diagonal matrix. And instead, we can just represent quite simply using these 7 rows in this table and those 7 formulas. And so, even very complicated time-dependent transition matrices can be very easily tackled using heRo3.
Any more questions coming in by the chat?
At the moment.
Okay. Well, I'd like to thank everyone all for joining us today. Hopefully, we've been able to answer some of the questions you had about heRo3, either if you're an existing user or contemplating using the platform. Once again, if you're a student or faculty member, there's an increasing volume of instructional materials, and there's support groups that are actually forming in different universities, so we're happy to put you in touch with folks like that.
Just following that question, are there publications that already used heRo3 in modeling? I'm guessing if someone published any models.
Yes, I think it was Joe Levy at Hopkins. Is that correct, Jordan, in terms of the publication that they sent us that it's already referenced heRo3?
Yeah.
Yeah, we can make that available if you just simply send an email to heRo3info@pai2.com or to Jordan or to me personally. We're happy to kind of plug you into that. This is a completely new technology, completely new paradigm, and it's going through a process of organic growth and dissemination. So there is a larger or increasing user group growing by the day, and we are all part and parcel of an effort to change health economics modeling that really has been stuck in a technology that's 25 to 30 years old for a very, very long time. So it's an exciting time in HEOR, and hope you'd like to become part of this period of dynamism and change. Thank you very much for joining us. We've appreciated any follow-up items, questions, issues post the webinar. Please feel free to reach out to us. I think by now you know how to reach us, and we will be sending a copy of the deck out to everyone by close of business today. Thank you once again.